Okay, I've turned my journal over and I'm going to be writing some conversion problems. Okay, so here's an example. We might see something like this. What that says is 2 kilometers equals how many meters? This is a math question. Well, in order to do this, we want to draw the staircase. Okay, so I'm just going to start over here. You can say the saying as you write. It helps me remember. Circle the unit. Also, you're going to write that the unit, because we're talking about length, how long something is meters. Think about that meter stick in the classroom. Okay, so here's what they're saying. They're starting at the top of the staircase. Why are they starting there? Because it's at kilo. So you put your finger at the top of the staircase, and then you decide, okay, am I moving up the staircase or am I moving down the staircase? So if I'm at kilo, where am I supposed to go from there? To meters. Look what the problem's asking, to meters. So if I'm at kilo, how many steps do I go to get to meters? It's 3. Did I go up the staircase or down the staircase? I went down the staircase. So you have to be watching for the 2 kilometers. Okay, so here's kind of how you solve this problem. You know that you're starting at 2. You know that you went down the staircase 3 steps. Okay, think about this if I'm using the base 10 number system. I'm going to turn my journal page back to the back page, and you should as well. Go back to the base 10 number system and look at kilometers and move it to meters. I'm going from something that's really large to something that is smaller. I'm going from the thousands place value clear to this unit, which is meters here. I'm going clear there. So I'm going from a large place value to a small place value. It means there's going to be a lot of these inside of a kilo. A lot of meters inside of a kilo. So remember, I moved down the staircase. And what are we supposed to do if we move down the staircase? We're supposed to multiply. So come back here. And so I know that 3 steps down, or anytime you're moving a certain number of steps, that's a power of 10. And 10 to the 3rd power equals what? 1,000. So I've got some information here, right? I know I started with 2 at the top of the staircase. I know I moved down 3 steps, which means I'm moving, or I'm multiplying by 1,000, or 10 to the 3rd. I know it's multiplication because I went down the steps. From something large going to something small, I multiply. Okay, so I take the 2, I times it by however many steps I went down, which was 3, but you can't just times it by 3, you're timesing it by 10 to the 3rd power, which is 1,000, right? So because of the 3 steps, I'm multiplying it by 1,000. So what is 2 times 1,000? It's 2,000. So I come back up to my answer line and I write 2,000. What that means is, if I were to break up 2 kilometers, there would be 2,000 meters. Think about that. Remember that 1 kilometer was 10 football fields. So 2 kilometers would be 20 football fields. Don't you think there'd be about 2,000 meter sticks in there? Yeah. So it makes sense. But I'm just showing you how we get there. We started at 2. We went down the steps, which means we were multiplying. How many steps did we take? 3. So it's multiplying by 10 to the 3 power, or the 3rd power, which is 1,000. So 2 times 1,000 is 2,000. That is how you solve a metric unit conversion. What is this called again? A unit conversion. To convert somebody or something means to change them or to have them be what you want them to be. Okay, so I started with kilo and I wanted it to be meters, and so I converted it from kilometers to meters. Using my staircase, using my place value system of knowing 10 to the third is 1,000. Where did I get the third? It was how many steps I took to get from kilo to meter. Let's try another one, because sometimes just practicing them is better than talking about them. So let's try another one. This conversion problem says 0.46 centimeters equals how many millimeters? This time I'm going from centi to milli. They both have meters at the end of them because I'm talking about length. So I take the original number, I place my finger on the staircase at centi, and find out if I went up or down and how many steps to get to milli. So I place my finger on centi. Did I go up or down to get to milli? Remember, this one in the middle is meter. It's not milli, it's the unit. So it's down. So I draw a down arrow. And I move down one step. So what does that mean? It means 10 to the first power. It's always a base 10, and then the exponent is how many steps you took. So remember, when you move down the staircase, going from something that's bigger, like centi, to something that's smaller, milli, larger to smaller, you're going to multiply. It means multiply. So you take your original number, times it by the step you took. And what does that equal? We've dealt with powers of 10 when there's a number that has a decimal. If you're multiplying by a power of 10, the decimal just moves to the right, one place. If you're dividing, the decimal moves to the left. But I happen to be multiplying. So that decimal moves and it becomes 4.6. So that makes sense because I have more tiny things inside of a bigger thing. This reads 0.46 centimeter is 4.6 millimeters. Okay, I'm going to put a box around these problems that we've solved. They are separate problems using the same method, and we're doing unit conversions. I guess I should make that plural. We're doing more than one. Okay, let's just draw little arrows here to remind us. Anytime we're going from something that's large to small, so large to small, we are multiplying. Anytime we're going up the staircase, we're going from something that's smaller to something that's large. So small to large, we divide. Okay, those are just some little helpful hints as we keep going through these unit conversions. We're going to try 2 more in our journal, and then we're going to move to our homework, okay, because there's a lot to do today. Okay, let's try another one. Let's try this one. I know it's a unit conversion. I know I'm going from centi to meter. So 105 centimeters is how many meters? Okay, so I first need to figure out how to get from centi to meters. Centi to meters. Oh, I went up the staircase. Centi to meters. So I'm going up, which means I'm dividing, and I'm going up 2 steps. So I'm dividing by 10 to the 2 power, or 10 to the second power. So remember, I keep the number. This time I went up the staircase 2 steps. So what that means, because I went up, is to divide by 10 to the second power. Right? So I kept the number. Because I went up the staircase, I have to divide, and it's like dividing by 10 to the second power. Do you know what 10 to the second power is? It's 100, essentially, right? But where's the decimal at in 105? It's at the end. And if I'm dividing by a power of 10, I don't move the decimal to the right like I was before. I move it to the left because I'm dividing. So because I'm dividing, I'm moving it to the left. How many times do I move it? 2 times because of that little 2. So if it's at the end and I move it 2 times to the left, what does it become? 1.05. So that's my answer. If I have 105 centimeters, that's little tiny little, remember centimeter was like our fingernails, 105 little fingernails, how many pencil boxes is that? Or no, meters. How many meter sticks is that? Centi to meter, remember? It's 1.05. So it makes sense to me why this number's smaller, because it's a larger distance, a longer distance. This is a bunch of little short distances put together. Gives you 1.05 meters. That's crazy to think about, like about 100 fingernails is the size of a meter stick about. Gross, huh? You're welcome for that. All right, box it up. Let's try the last one before we move on to our homework. You feeling like drawing another staircase? I think we should. It's always fun. They can be really steep stairs or really wide stairs. It doesn't matter. But you're going to say the phrase, Kilo hecto, or King Henry, whatever you want to do. Kilo hecto. Deca. Unit. I know you probably want to put meter right there, but it's really confusing because you have a little m on the bottom of your staircase. So, kilo hecto, decameter, but it's off to the side, or deca unit, deci, centi, milli. So you have the lowercase d, lowercase c, and the lowercase m. Okay, I've redrawn the staircase. It's just so much fun. Now let's try another problem. You ready? 32 meters equals how many millimeters? Okay, put your finger on meters, which is right there in the unit, right? It's the ones place. Find the milli, because I'm going to millis. Am I going up the staircase or down? I'm going down, which means multiply. How many steps did I go down? 3. Do you understand why we put 10 to the third? You should at this point. What's the number in front of that, though? You keep the first number. You're just going to keep that. And you're just doing 32 times 10 to the third. Do you know what 10 to the third is? It's 1,000. So essentially, this is 32 times 1,000. Sometimes it's easier for me if the number's a whole number, if I don't do decimal movement, but if I just think logically. What is 32 times 1,000? It's 32,000. Seems like a big number, but they're teeny tiny lengths of pencil tips. Yeah, if I have 32 meter sticks, I'm going to have a lot of pencil tips to equal that length. So it's logical, even though it seems like a lot. I'm going to do that arrow again. We moved a little faster on that one, so hopefully you're catching on to what we're doing. Okay, I told you I would help you with your homework because it is crazy. We take all of these skills that we have of place value and moving decimals and multiplying and dividing and using powers of 10 and staircases and the fun phrases. And then we take all that knowledge and we put it together with the stuff we practice for the few lessons in Unit 6, multi-step story problems. So we take all of this information, we put it into these multi-step story problems, and it is really difficult. It can be really difficult. So let's work through a few of them, but make sure that you're paying attention because you will not be able to do this on your own if you aren't focused. So hyper-focus, okay? Pull out your homework, 8.1. Please leave out your scarlet color because you need to put your name and number on the homework side, and then you need to underline the date. You need to actually write the date, and then you can see that I had some fun drawing another staircase. So you need to do that as well. I'll give you a couple seconds to get that all done. Take a look at how numbers 1 through 10 are all just unit conversions. Moving up and down staircases, moving decimals, knowing what's happening, knowing which way to move the decimals. Remember, if you move down the staircase, you move the decimal down the number line or to the right, okay? Or down the place values is what I should say, to the right. If you go up the staircase, you're moving up in place value or moving up to the left. That's how you can remember it too. Okay, you should have that staircase written. You should know how to do like 1 and 2 and 4, all of these problems in here. I want to help you with 3 and 10, and here's why. It's because they give you the answer and they're just looking for the measurement. So they're saying, do you know what the measurement is? Look at number 3. 251 kilometers equals 251,000 what? So you're just going, okay, well, they clearly moved the decimal to the right, right? How many times did they move that decimal to the right? Well, here was 251, and so they must have moved it 3 places to the right. So look at the staircase. Start at kilo. And what measurement is 3 places moved down to the right? It's just the meters. So that's how you answer that. Pretty awesome, huh? You could actually write the word meters if you wanted, but just 1 M would work. Would 2 baby M's work? No, because that means milli. Okay, let's try number 10. Okay, we have 2.92 centimeters, so put your finger on centi. And where did that decimal move to? It looks like it just moved 1 place. So you were going to be doing 10 to the first, and the decimal moved to the right. So it had to be going down in place value, because whenever we move down, right, we're multiplying or we're moving to the right. That might be helpful for you to draw that. Whenever we move up, we're dividing or moving the decimal to the left. Okay? So in this case, I am on centi, and the decimal, it gave me more. It gave me 29.2. So it must mean that I multiplied, because I'm going to have lots of little teeny tiny things in something bigger. So this has to be millimeter. Just see if it worked. From centi to milli was one step, moving down the staircase to give me multiply. One step down the staircase meant I was multiplying. So that number is going to get bigger. Is 29.2 a larger number than 2.92? Yeah, so it makes sense. Okay, I don't really want to spend a whole lot more time on those. I think you can do the unit conversions. Let's go ahead, though, and try, number 11. Jason ran 325 meters farther than Kim ran. Let's circle that. Kim ran 4.2 kilometers. Oh, no. We have one measuring in meters and one measuring in kilometers. It's like having fractions with unlike denominators. You can't do that. You're going to have to convert one of them so that they're the same thing. So that they're like having the same denominator as a fraction. Having the same unit is like that. So how many meters did Jason run? Because they're asking it in meters, let's convert the one that isn't meters to meters. So we're going to take the 4.2 kilometers into meters. So right off to the side. We're just setting up our own conversion problem is what we're doing. So I'm telling you, I want you to go from kilo to meters. So we're going to come up on our staircase and go from kilo to meters, which is 3 steps to the right or bottom, going down. So I'm going to take this number, and because I moved down the staircase, I'm going to multiply it by 10 to the 3rd power, which means I'm going to move that decimal 3 places. To move it 3 places, I would have 42 if I just moved it once. So I'm going to have to move it even more. Does that make sense? So once would be 42, twice would be 420, 3 times would be 4,200. I'm not done. All I did was convert Kim. Kim went 4,200 meters. Okay? So Kim ran 4,200 meters, but Jason ran 325 meters farther than Kim did. Ah, farther than. You have to add his distance to her distance. How many meters did Jason run? Then it asks us to estimate to check our answer. We'll do that in a minute. But we're going to answer it by Jason ran 4,525 meters. Here's how I would estimate this, okay? I would estimate just by saying, well, 4.2, my estimate, 4.2 kilometers is close to 4. Okay? So 4 times 1,000 is about 4,000. Is, when I'm talking about thousands, is 4,525 pretty close to 4,000? Yeah, but plus you weren't just doing 4, you were doing 4.2. So it'd be 4 times 1,000 equals 4,000 plus a little more. That is how I would estimate that. I don't need an exact answer on that one. I'm just showing you that it's probably close because you'd be doing a little more than 4,000, and 4,525 is a little more than 4,000. So it worked out. All right, number 12. On each of 3 days, okay, so we're dealing with 3 days, Derek rode 6.4 kilometers to school, 150 meters to the library. Uh-oh, we got meters and kilometers again. And then 500 meters back home. How many kilometers did he ride for the 3 days altogether? Wow, this is awesome. I love problems like this. There's so much going on. If we want to find out how much he did for 3 days, I would recommend we find out how much it was for 1 day and then just multiply it by 3. Okay? So let's start doing that. They're asking for it in kilometers. So I would change both of these to kilometers real quick. So I'm going to do 150 meters equals how many kilometers? And then I'm going to have to do 500 meters equals how many kilometers? I already know the way to school is here. He's already got it in kilometers, so I don't need to worry about that. Okay, meters to kilo. Use your staircase. Put your finger on meters. It's in the middle, and go to kilo. It's up the staircase 3 times, so I move the decimal to the left 3 times. .15. I could put .150 if you want me to. We can, it's fine. Okay, so guess what? It's going from meters to kilo again. So just move it 3 times. And it becomes .500. You could just say 0.5, but it might help us to put those zeros when we're adding. So, okay. So, now what do? I know that he went 6.45 to school, 0.150 to the library, and 0.500 to back home. So I have to add all these together. So I have some new numbers here. I have this number and that number. I have to add 0.150, 0.500, and 6.45. So let's come over to the left and go up kind of high so we can use space later. And let's just add all those together. We're trying to find out how much he did in 1 day, remember? So we're going to take 6.45, 0.150. Oh, you know what? It's not helpful to have the zeros on that one because the 0 would be out here. So I'm not going to use it. And then 0.500, it's not helpful to keep both zeros. It's helpful to keep one of the zeros. Look how I'm lining up the decimals. Do you know the button man, the button man, the button man? Do you know the button man? He lines the place values up. Or the decimals up, whatever. So I didn't need to keep the zeros on all of them. If you did have the zeros, you could just add a 0 onto this one, but that's fine. So add them up. See how we're using all of these skills? It's so awesome. I got 7.10, which isn't that just the same as 7.1? Yeah, that is for 1 day. So in 1 day, he went 7.10. They're asking, how far did he ride for 3 days? So now what do? You have to multiply by 3. You have to take that total and multiply it by 3. Okay. Instead of doing 7.10, I'm just going to do 7.1. And now I'm using my decimal skills to multiply. Guess what that means? Decimal box. Thought you got away from those. Sure didn't. What's the number that goes in the decimal box? Go ahead and write it. And go ahead and do the multiplication. Solve it all the way to the end. How many kilometers did he ride for the 3 days altogether? he rode 21.3 kilometers altogether. Isn't that so fun? Ugh, I know you think I'm a math nerd, and I'm okay with that. These problems are going to take a lot of time. There's a lot of things happening. You have to think it through, and I'm excited to see how you do. So spend the rest of the time doing 1 through 10, and then all you have to do is number 13 and 14, and they are a little difficult, so spend some time on them. You might want to ask for some help at home if you're struggling. I'm excited to see how you do. On the remembering side, my backside didn't have anything. On the remembering side, because those problems are so difficult, the remembering's so easy. Never mind. You can do the remembering. Look how fun it is. I love the remembering side. Okay, I'll stop chatting so you can get right to work. Go ahead and finish homework and remembering 8.1. You do not need to worry about Think Central today. Enjoy.